Hey guys, today there's again a small tutorial, but this time of a physical nature, but of course around the topic of diving. I asked myself the question, what is pressure anyway? We all know pressure, be it as a display from our Finimeter to show us how much air is still in the bottle, or as you know it from the textbook, at the water surface there is a pressure of 1 bar, at 10 meter depth 2 bar, at 20 meter depth 3 bar, and so on. So what is this anyway? So first of all, pressure as a unit means nothing more than that we have a force F, represented here as an arrow, acting on a surface A. What units does the whole thing have? I use the metric system here. The force has the unit Newton, abbreviated with N. I will come to that in a moment. And the surface A has the unit square millimeter, or also square meter, square centimeter, and so on is possible. We will use square millimeter for now. So pressure P is force per, or also force divided by area. So F divided by A. If we insert the units, we get Newton per square millimeter. But what the hell is a Newton now? Newton is the unit of the force. A force can act, for example, by a weight which simply stands around. In this case, a weight force acts on the surface, and we simplify that a weight of 1 kilogram exerts a force of 10 Newton. Who would like to know the whole now more exactly? The weight force computes from the formula mass times acceleration due to gravity. Mass is the weight and the acceleration due to gravity is 9.81 meter per square second at a standard location on Earth. Though we calculate 1 kilogram times 9.81 meter per square second, the units result then to a Newton. There I do not go now more in detail on it, and we receive 9.81 Newton. Thus is in a very good approximation 10 Newton. Well, now we know the two units, Newton and square millimeter. Let's summarize the most important again. The pressure P is force divided by surface with the units Newton per square millimeter. That's the important thing for now. How can you imagine the whole thing? Figuratively, 1 Newton per square millimeter would be the pressure that a bar of chocolate weighing 100 gram or 0.1 kilogram would exert on an area or on a surface of 1 millimeter by 1 millimeter, as shown here. This may be a bit abstract, but let's take a look at a diver's example. We could also say 10 Newton per square millimeter, which would now be the pressure that 1 kilogram of dipping lead would exert on an area of 1 square millimeter, thus 1 millimeter times 1 millimeter, as shown here in the picture. So we know that pressure is force per surface, N divided by square millimeter. But where does the bar come from that we talk about all the time in diving? In principle, it's quite simple. We'll just look at a few other ways of writing how we can represent the pressure. So we've already learned that one way to represent the whole thing is to write 1 Newton per square millimeter. Now, there's nothing to stop us from making it a little bit bigger by saying Newton per square meter. Assuming that the pressure is now acting on every single square millimeter and is evenly distributed, therefore a very large number comes out, namely 1 million Newton per square meter. Here, Monsieur Pascal has distinguished himself with his research very much Why, we can also say that 1 Newton per square meter is 1 Pascal. Or in the English-speaking world, where the metric system is not universally used, pound per square inch, short PSI. 1 Newton per square millimeter corresponds to 145.04 PSI. So, and now we really come to the bar, namely 1 bar is 0.1 Newton per square millimeter. So in principle, all the quantities are smaller by a power of 10. A power of 10 means divided by 10. 1 divided by 10 would be 0.1, which is how the 0.1 Newton per square millimeter is arrived at. And we can now calculate this for each value in the table. Okay, now let's finish with a visual example of what we can do with this knowledge and what kind of masses and forces act on us during diving. We consider how many kilograms of water act on us at a depth of 10 meters. I took a picture from my vacation in Egypt. I don't know exactly how depth it was there. Let's just say it was 10 meters. And we know that at a depth of 10 meters, 2 bar are acting on us. Minus the 1 bar due to air at the surface, the water alone still has an effect of 1 bar on us. Now we can look at the table from before again. Sure, though 1 bar is 0.1 Newton per square meter, and we have now already learned that for simplicity we calculate with the acceleration due to gravity of 10 meters per square second, not with the exact value of 9.81. So we have to divide by 10 again to get the weight that acts on 1 square millimeter, 0.01 kilogram per square millimeter. That doesn't sound so much at first. But let's take a closer look at the whole thing. According to Wikipedia, I googled a bit, an adult human has an average surface of 1.73 square meter. The values are a bit old. In the example, 1 bar equals 100,000 Newton per square meter. You can have a look at the table 2 slides before. There we put the surface of the human being, so we want to know how big the forces are in Newton, which act here on us with a surface of 1.73 square meter. The forces are here now the unknown x. We convert the whole to x by multiplying on both sides with 1.73 square meter. In the next step, in the last line, the square millimeter are cut out and we get 173,000 Newton, which divided by 10 to get the kilograms is 17,300 kilograms of water breathing on us at the depth of 10 meters. Quite a lot. I personally would not have thought that it's so much, but it does not make it less interesting. Quite the opposite. I hope you had fun with this little tutorial. Let me know if you want to see more videos like this, and if you liked it, please leave a like or write me a DM. For feedback of any kind, I'm of course just as grateful, whether we are DM or in the comments. Or otherwise, still a few nice dives and all time good air.